So last lecture, I think we have seen the applications of first law of thermodynamics to chemical reactions or chemically reacting systems. And in that, I think got we have studied the standard heat of reaction. That reactants are reacting and they are forming the products. Reactants enthalpy reactants with different products heat or product enthalpy is different or maybe sometimes same. So depending on the conversion of reactants when they are converting into products, maybe for that reaction we have to supply some amount of heat, or sometimes heat is released, or sometimes heat is not required. So that kind of reactions we may consider as endothermic, exothermic, or thermoneutral reaction. That was afterwards we have studied the numericals. We have gone for the different kind of numericals that are going to be asked on standard enthalpy of formation reaction and standard enthalpy of combustion reaction. So we know that formation reaction means what? From different constitutes element. If only one single compound product, single mole of a product is formed, that reaction is called as formation reaction. So reactants may react, reactants may react, and they are forming. The reactants may be different. It is not the case that only one reactant, only one mole of reactant will react. No. So different reactants with different moles, number of moles, if they are reacting, but product should be formed as a only one mole of a single compound. So that kind of reactions are called as formation reaction. And if we know the formation enthalpies of the elements, that is maybe reactants and products in the reaction, then we can calculate the entire heat of reaction, standard heat of reaction for a given chemical reaction. So that we have completed yesterday. If formation enthalpies are given in the numerical and they ask us to calculate the reaction of the given chemical heat of standard heat of the given chemical reaction, then simple formula we have to use. Who will tell that formula? Anybody? Anybody of you? That simple formula, what is when formation enthalpies of elements are given and we have to calculate the standard heat of the given chemical reaction, then which formula we have to use? Anybody? Yesterday only we have solved the numericals. Somebody can take initiative.
Standard
enthalpy.
Okay, okay, some one can speak. Others
Enthalpy associated with product minus enthalpy associated with reaction.
Yes, and that they have given the kg per mole enthalpy of that formation of product and number of moles into that enthalpy of element that we can calculate. Similarly, there is another kind of reaction is called as combustion reaction. So combustion reaction is called as, anybody? Is what? Combustion is what? Anybody?
reaction of element with oxygen.
Or it is exothermic reaction, or it is oxidation reaction of the element, where that element is reacting with oxygen and they are here releasing the heat. Always all the combustion reactions are exothermic in nature. Therefore, all combustion enthalpy of all elements is always negative because they are the heat is releasing from that system. So another case is there that if combustion enthalpies are given of elements and we have to calculate the standard heat of a main chemical reaction, then what formula we have to use? Anybody? Asmita,
combustion enthalpy of reactant minus combustion enthalpy of product.
Very good. Combustion enthalpy of reactant minus combustion enthalpy of product. And when it is formation enthalpies of product minus formation enthalpy of, or enthalpy associated with product minus enthalpy associated with the reactant. So in that way we have solved the numericals. I think everybody understood the numericals also. Now today we'll go for the second law of thermodynamics. This is a limited syllabus is there for us to of the first law of thermodynamics. Actually, there are all the applications are related to first law of thermodynamics. So therefore, first law of thermodynamics is valid everywhere, but still it is having many limitations. So today we'll start why there is need of second law of thermodynamics, and then afterwards we'll start the devices required for defining the second law of thermodynamics, that is heat engine, heat pump, refrigerator, what these devices are there. And then afterwards we'll see the statements of second law of thermodynamics in detail. That is two statements are there. One is Kelvin Planck statement, another is Clausius statement, that everybody knows. Then these two statements we have to learn, and where though these two statements are different, but if they are, we want to use them in a combined form, combined device, in only one in only one device, common device, then these two statements are related, strongly related to each other. So that is called as equivalence of second law of thermodynamics. That, if possible, that today we will today we will see. So let us now we go for the uh, second law of thermodynamics here. Only this chapter is same, but here okay, here now we screen is visible to all. Somebody can reply.
Yes, sir.
Okay. So this is I think second law of thermodynamics very very important, as not as per as the thermodynamics syllabus is concerned, but also here for the UPSC examinations of engineering, GATE mechanical engineering examinations. So these basics of these laws are very much important. Okay, so therefore, now first of all we see the limitations of the first law of thermodynamics. I think first of all we'll start from your side. So we have learned, you have learned the first law of thermodynamics and the second law of thermodynamics, at least introduction in your subject basic mechanical engineering. Am I right? Somebody can reply or chat. Anybody of you learned or not?
Yes, sir.
Ah, so yes, okay. Asmira sir, what is okay. So we'll tell the limitations. We'll start so that I can understand what you have learned in the for limitations. What limitations you know for the first law of thermodynamics? Let somebody can explain.
Sir,
Yeah.
first law of thermodynamics does not tells us that in which direction heat is converted into work. It also does not define that under which condition heat is supplied.
Okay. Good. Good. Trying. Promotion is trying. Another somebody. Okay. So first is there that here heat is always flowing from hot temperature to hot temperature system to a lower temperature system, and naturally heat will not flow from lower temperature system to higher temperature system. So this is the natural condition. This is the truth. Okay, but first law of thermodynamics is not speaking about it. Only first law of thermodynamics, what it is telling, heat is converted here, energy can neither be created nor be destroyed, but it can be converted converted from one form to another, and total energy of the system or universe remains constant. So it doesn't speaks about the direction of the process. So first is there, that is the heat flows from, always flow from higher temperature to lower temperature system, and it is not explained by the first law of thermodynamics. So first limitation is what here, that here first law of thermodynamics doesn't speak about the direction of a process. Okay, so energy transfer can take place in either direction. That is according to the first law. It does not specify the direction of energy transfer. That is heat higher temperature to lower temperature. According to first law, it may be possible that heat is transferring from lower temperatures to higher temperature system also there. So this is the limitation. First limitation is there, that first law of thermodynamics is a direction-less law, or it doesn't have any kind of, doesn't speak about the direction. Okay. Then first law of thermodynamics is not, another thing is there, that only first law of thermodynamics is telling that heat is converting, heat is one of the energy, work is one of the energy for, okay, heat is converting into work and work is converting into heat. But how much amount of heat can be converted into work is not explained by the first law of thermodynamics. So uh, here all work can be converted into heat, but all heat cannot be converted into work. So here what is indication is there, that work is a high grade type of energy, work is a pure form of energy, work, and heat is a low grade type of energy. So first law of thermodynamics doesn't speak that work is not gradation, it is not quality, means it is a heat is a low grade type of energy and work is a high grade type of energy. So it is doesn't mention about the quality of the energy. So therefore we say that first law of thermodynamics is not a qualitative law, it is not a qualitative law. Okay, why? Because it should differentiate that all amount of work can be converted into, because pure heat, pure work can be converted into low grade, all low grade heat, but all heat cannot be converted into work. So for example, in our IC engine, now you are learning that subject, internal combustion engine, whatever the heat we are supplying to the here fuel is not converting into work, but some part of it is lost, rejected to exhaust gases, oil, cooling water. Okay, so all amount of it cannot be converted into work. So if you see the diagram here, so if it is afterwards I will explain in that case what is mean by source. So we are now going for that, but before that, here let us consider this as a source temperature T1. So okay, if Q1 amount of heat is coming from the source, okay, it may be any kind of source, okay, fuel, energy, and it is supplying to, let us consider that a engine. So here all amount of heat, that is Q1, is not equal to W. If it is there, it is here, according to first law, Q1 is equal to W, because it is telling that heat is converting into work, work is converting into, but really it is not there. It is some amount of heat have to be rejected to the surrounding, to the atmosphere. Let us consider this as a another sink temperature. So we'll afterwards will define what is meant by source, what is meant by sink. Okay, so there in that case, here T1 Q1 heat is coming and W is means what? Q1 is cannot be equal to W. Okay. So therefore we can say that it is not also quantitative law, means it is not telling us how much amount of heat is converted into work. So first thing is there, that here all here it is not differentiating, heat is a low grade type of energy, work is a high grade type of energy, and at the same time it is not explaining that, it means it is not a qualitative law. At the same time, how much amount of heat can be converted into work, that quantity also it is not explained. So it is not a quantitative law also there. Then in power plants example, all amount of heat is generated from a combustion of coal is not converted into work, but portion of heat input it has to be rejected into the condenser. So all amount of power plant also is turbine. If you are in turbine, now steam power plants we are doing. So boiler, I think I have explained. But here is boiler. Okay. Then afterwards it is going to the steam turbine, and in the steam turbine we are getting the work. Okay, now I am drawing a rough diagram. Okay, so this is steam turbine. I will mention yes, it is steam turbine. Okay, and here this steam turbine, some amount Q1. Let us consider that here Q1 amount of heat, thermal energy supplied to the steam turbine. W amount of is produced, but some amount of heat it have to always reject to a condenser. So therefore condenser is necessary. Or if condenser is not there, some amount of it is have to exhaust to the atmosphere. Okay. If condenser is there, this is condensing, and again it is with the help of pump. Here it is going to be for this is pump, this is boiler, this is condenser. Okay. So here in power plants also there, all amount of heat generated cannot be converted into work. Some amount of heat, that is, let us consider this as Q2 amount, is to be transferred to the condenser. So therefore first law of thermodynamics is directionless law. Then first law of thermodynamics doesn't speak about the quality of the energy, means not you can mentioning heat is a low grade type of energy, work is a high grade type of energy. And another thing is that means why? Because all work can be converted into heat, but all amount of heat cannot be converted into work. Okay. So that way, what first law of thermodynamics tell us? Interaction interpretations are there. So first law of thermodynamics states work can be converted into heat and heat into work. Only it is explaining. First law makes no distinction between forms of energy, silent about the possibility of energy conversion, heat and work, that I already have discussed. First law is not sufficient to predict whether system will or will not undergo particular change. First law of thermodynamics is a necessary condition, but not sufficient condition for a process to take place. Then another thing is there that all the natural processes are happens in only one direction. So reverse of them is not possible. And first law is not explaining that thing. For example, water is flowing from high head, high potential head to low potential head, or high height to low height. So naturally, but we cannot pump the water, okay, or any fluid from low head to high head. एखाद्या जमिनीवरून उंच ह्याच्यावर आपण नॅचरली वॉटर कधी आपण फ्लो करू शकत नाही. त्यासाठी आपल्याला एक्सटर्नल वर्क लागेल, त्यामुळे पॉसिबल होईल. पण विदाउट एक्सटर्नल वर्क नॅचरली वॉटर कॅनॉट बी फ्लो फ्रॉम एअर high low head to high head. Okay, so all natural processes happens in only one direction, means from high to low. For our wind is flowing from high pressure to low pressure, low pressure to high pressure, it cannot be flowing. So all the natural processes are flowing in only or happens in only one direction, and the reverse of them is not possible. So these all these limitations are not spoken by first law of thermodynamics. Now here in our class notes, we'll go for class notes. Okay, now we'll go for class notes. So this is useful because these notes I am going to provide you. Is it visible now? Somebody can tell, somebody can. So that this is we have to, if they are asking in the examination, we have to take use of this. Am I right? Is it visible? Chart, or somebody can chart, or
yes,
somebody can, yes, okay. So it doesn't specify the direction of process. It is law of conservation of energy only. It is not a quantitative law. That is, if 100 kilojoule of heat is supplied to a heat engine, then fails to explain how much quantity of work can be obtained from the engine. It is not a qualitative law. It doesn't explain that heat is a low grade type of energy and work is pure form of energy or high grade type of energy, because all amount of work can be converted into work. All amount of work can be converted into heat, but all amount of heat cannot be converted into work. And it fails to explain that all amount of heat cannot be converted into work, but all amount of work can be converted into work. So this is a supplementary of third point. Then it does not specify that at low temperature. Now here also one thing is there. This also not explained by the first law of thermodynamics. It does not specify that all low temperature, at low temperature conversion of heat into work is less, and at high temperature conversion of heat into work is more. So it depends, means conversion of heat into work depends on the temperature, is also not explained by the first law of thermodynamics. So obviously at the time of first law of thermodynamics, temperature, where temperature scale was not defined, so therefore it doesn't speaks about the temperature anywhere. It is speaking about two energies, that is, and pure two types of energy, mainly heat and work. It doesn't speak about the temperature. It fails to explain the truth that all spontaneous or natural process happens in only one direction. So or the reverse of them is not possible. The first law of thermodynamics does not explain feasibility of a process, means whether the process will happen or reversible process will happen or not. That is reversibility, is whether the process is reversible or not. That cannot not be explained by the first law of thermodynamics. It is telling only that heat is can be converted into work and work can be converted into heat, or it is a law of conservation of energy. Okay, so it does not specify about the reversibility of the process. So same thing. Now with this, these are the limitations. Therefore we have to go for the limitations of the thermodynamics. Here second law of thermodynamics. Understood now? All limitations understood by you? Understood? Please mention in chat box so that I can get confidence. Yes, sir, understood. Asmira sir over there. Others, please reply. If 4 to 5 reply is coming, then I will continue. Please reply. Abhishek Dado, yes, sir, good. If doubts are there, you ask me, because in examination they are going to ask what are the limits and prerna work one day. Understood, very good. Other, please reply. Pawan Shinde, yes, sir, okay. So, okay, others, those are in the lecture, they have to tell us. Vedanta, yes, sir. Pradeep Dhumali, yes, sir. Good. So that I will get your names also there, who is interacting, who is more interacting. So this is one of the, you can create impression on me that way, how you are listening. Okay. Now we'll go to the second law of thermodynamics, and for that some definitions we have to learn. Okay, so here what is first definition is there, that thermal energy reservoirs, or we say that reservoir, thermal reservoirs, thermal energy reservoirs or thermal reservoirs. What is thermal reservoir? So write down in your notebook also. Thermal reservoir, it is defined as large body or a system, large body or a system to which abundant amount of it is supplied, abundant amount of it is supplied, or abundant amount of it is rejected, still its temperature remains constant. That will be called as thermal reservoirs, thermal energy reservoirs, or we say simply it is thermal reservoirs. What is that? If abundant quantity of heat, let's consider this as a thermal reservoir. Okay, so this thermal reservoir, if abundant Q1 amount of heat is taken from this reservoir, still its temperature remains constant. The temperature is not changing, though Q1 amount of it is, lot of amount of Q1 is taken out from this that reservoir, or if here it is another reservoir is there, Q2 is there, Q2 is there, abundant amount of it, if it is supplied, then also its temperature remains constant. So means though abundant amount of it can be supplied to it, or abundant amount of it is rejected from it, its temperature remains constant. So that system or that body is called as thermal reservoir. Very here this is very important. Temperature is remaining constant, though a lot of abundant amount of heat is supplied or rejected. Okay, but temperature is always remaining constant. So that body or that system is called as thermal energy reservoir. Everybody got it? Chat box, please, please. It's very important. Thermal energy reservoir. That is a C. If in C, if you take C is a large reservoir, and if you take uh, so many streams of rivers are here going joining the sea. Sometimes when lot of flow we can take out from the sea, but level of water in sea always remains constant. So that we call it as a big reservoir. Okay. So here is thermal reservoir. It is related to heat. Okay. Though abundant quantity of heat is supplied or rejected from the body, its temperature always remains constant. हीट किती जरी घेतली आणि किती जरी त्याला सप्लाय केली तरी त्याचा टेम्परेचर काय राहतं कॉन्स्टंट. अशा सिस्टीमला आपण म्हणतो थर्मल एनर्जी रिझर्वायर्स. अंडरस्टूड? Now there are two types of thermal energy reservoirs. There are what? Two types of thermal energy reservoirs. One is anybody? काय कुठला असतो? Anybody? There are two reservoirs. This diagram also showing two reservoirs, two thermal reservoirs. Anybody? Nobody is knowing which are the two thermal reservoirs. Now everybody got thermal energy reservoir definition. It base for us. Please reply, please respond so that somebody is replying. Abhishek Zado, yes sir. Okay, understood. Okay. Smita Sarvati and Abhishek are only understanding. Others, please reply. If it is not understanding, I will repeat once again. Dattatreya is a repeat definition. Okay, Prerna one. Okay, so don't worry about definition. I am showing that after our notebook class notes. Okay, so thermal energy reservoirs are those body or system to them if abundant amount of heat is supplied or abundant amount of heat is rejected from them, its temperature remains constant. So that body or that system is called as thermal energy reservoir. If abundant amount of heat is supplied or rejected, but their temperature remains constant, so that body or system is called as thermal energy reservoir. Is it okay, Prerna ji? Now understood, or shall I repeat once again? Yes, sir. Okay. So temperature remaining constant. Now two thermal reservoirs are there. Now you tell me that two thermal reservoirs or types of reservoirs we can say. Types of thermal reservoirs. Anybody? One is what? Anybody? Nobody is okay. So I will. It is one is what? Source. What is that? One thermal reservoir is called as what? Source. Now, what is the definition of source? Anybody? BME source means what? Source means what? It is a thermal. Okay, somebody is replying. Source and sink. Prathamesh, very good. Prathamesh. Okay. Source and sink. Types of source and sink. Correct. So these are the thermal reservoirs. Prathamesh. Okay, good. So source and sink. So source is a thermal reservoir which is at high temperature. Only that definition is sufficient for source. Okay. It is a thermal reservoir which is at high temperature. Thermal reservoir which is at high temperature. And from that only we can take the heat. Thermal reservoir source is a what? Thermal reservoir which is at high temperature. Write down in your notebooks. These are the some high temperature. So this is simple definition of what? Source. Okay, thermal reservoir at high temperature is called as source. Now everybody got the source, and then sink. Another thermal reservoir is what? The types of thermal reservoir is what? Sink. What is sink? Anybody? Now sink can be defined. Anybody of you chart box? Yeah.
At low temperature.
Very good. It is a sink is a thermal reservoir which is at low temperature. So it is low temperature thermal reservoir. Sometimes it is what, instead of sink they are writing that low temperature system or low temperature thermal reservoir. It is nothing but what? You write down. The sink is what? The thermal reservoir which is at low temperature, and write down source is a thermal reservoir which is at high temperature. Okay, everybody got it? Now before that, again we'll go for that our class notes, so that will more definitions are clear in our class notes. Now thermal reservoir, it is a large body or system from which abundant quantity of energy in the form of heat can be extracted, or to which and abundant quantity of heat is added, its temperature always remains constant. So this is called as, here this will be here definition of thermal reservoir. Now next is what? Source. Very only one line definition is what? Source is a thermal reservoir which is at high temperature. Okay, and sink, it is a thermal reservoir which is at low temperature. Everybody understand? Please write. Okay, please write the definitions of this now in a short form. Yes, sir. Prathamesh, now okay. Prathamesh is our friend now. Interested today. He is taking initiative. Good. Good, Prathamesh. Source, sink. You read in short form definition. I am supplying these notes to you, or it is available in our study material. It is basic class notes. So class notes can be used, but nowadays PPT we have to prepare, and PPT, all PPTs and class notes are not matching. So therefore, I am taking both, help of both. Okay. Now here we have to define, before going for defining the statements of second law of thermodynamics, we have to define some of the devices that is to be used for the that is used to be used for the defining statements of second law of thermodynamics. Okay, now in that case, first is there, it is called as heat engine. The device, it is called as what? Heat engine. Okay, so what is heat engine? Anybody? In your language, you tell. In simple language, here little bit exhaustive language is used in our PPTs, but anybody of you, heat engine म्हणजे काय असतं, तुम्ही काय शिकला?
Heat is a device which is heat is converted into mechanical.
Heat is converted into mechanical. Very good. So input is what? Heat, and output is work. That device is called as what? Heat engine. So what heat engine is doing now here? So heat, it is a device which working in a cycle converts energy in the form of heat into work. Heat engine converts heat into work. Okay, so means input for the heat engine is work. There are several types of heat engines, but they are characterized by the following. So which are heat engine? So which any device, maybe it may be steam turbine, it may be our IC engine, it may be external engine, who is taking heat as the input and developing work as a developing work or giving output as a work. That any device is a heat engine. Don't limit your definition to heat engine means what? Only IC engine. It is not the case. Anything which is taking heat as the input and delivering work as the output is called as heat engine. So therefore, don't limit your definition to IC engine only. Engines means we are considering that heat engine. So heat is the input and work is output for those devices. It may be steam turbine. It may be here ice internal combustion engine. It may be anything which is taking heat as input and developing work as output. That is called as heat engine. So they reject remaining waste heat to low temperature. Now we'll go forward here definition. Steam engine, very good. Steam engine. Pratham Song is doing that. Steam engine, any kind of engine. It may be steam as a heat. Steam engine. It is IC engine. It may be our what steam turbine is steam engine. Okay. So these are considered as here heat engine. Okay. So there are receive heat from a high temperature source. Okay. Oil, nuclear reactors, nuclear reactions are there where nuclear energy, nuclear thermal power plants are there. Their energy is in the form of heat from nuclear reactors. Okay, and then they convert part of the heat into work, and some amount of it is to be rejected. They operate in a cycle. So it is a cyclic operating device. You can say it as it is a cyclic operating device. Okay, now okay. Heat engine. It is they are given that example steam turbine. Okay, is one of the heat engine. So steam is coming from the boiler. Okay, so the steam is coming from the water boiler. This steam power plant. Steam is coming from the uh, the steam is coming from the boiler. This boiler, you can say. Water is converting into steam. Steam is heat engine. Now here it is having Q1 amount of it will be Q1. Like it is considered turbine developing work input as a heat. Q1 amount of it is considered Q1. Okay, and it is developing WT amount of work. So some work is required for pump, so that afterwards will go for net work is equal to WT minus W pump. Pump also have to supply some work. So here this much amount of work is generated. W turbine minus some work we have to give for pump. So this is net work. W net we can say it as a W network output of the system during cyclic process. सायकल मध्ये पंपला आपलं वर्क द्यावं लागतं आणि टर्बाइन आपलं वर्क डेव्हलप करतं. WT minus WP and heat as input. So this is one of the heat engine, which is what steam power plant is one of the heat engine, the steam engine. Then this is now here is here source. What source means what? Thermal reservoir which is at high temperature. So always here heat engine is taking heat from high source which is at high temperature, developing W amount of work and rejecting Q2 amount of work. So this will be Q2. Okay, so Q2 is equal to if you balancing, if you apply. So if you balancing apply, then what we have to do is there. So this is Q2. Okay, so balancing means incoming is equal to outgoing. We have to what heat engine incoming is equal to outgoing. So what is incoming? What is incoming? काय असते इनकमिंग काय येते इंजिनला इनकमिंगला काय येते एरो दाखवते एनीबडी इनकमिंगला काय दाखवते इथं एनीबडी chat box also you can mention or you can unmute yourself and heat is coming. So what is what that amount of it we say Q1. What is that Q1 amount of it? Okay, so it is what Q1 is coming as a incoming. What is outgoing? Incoming is equal to outgoing. It is called as first law of thermodynamics. Here incoming is equal to outgoing. So mathematically, if you here we should not consider the direction. What is if it is supplying, it is positive, work is negative. So incoming is equal to outgoing. So Q1 is equal to what? Now what is outgoing? Work is developing from the engine. W is outside. Arrow is what? Out towards outlet. And here Q2 is outlet. So here W plus Q2. Okay. Therefore, W is equal to what is Q1 minus Q2 means amount of heat. Therefore, henceforth we are getting one formula. What is that? Work obtained from an engine is equal to what? Heat supplied minus heat rejected. W is equal to Q1 minus Q2. And here what we have to apply? Incoming is equal to outgoing. So we should not write in everywhere, but we should remember that engine incoming is equal to outgoing. Understand? So W is equal to, therefore Q2 is equal to what? W minus Q2 is equal to here Q1 minus here it is not Q1, it is Q1. Okay, Q1 minus W. So Q2 is equal transfer here, W transfer, it is Q2 is equal to Q1 minus W. Okay, so it is heat engine. What is it is doing? It is taking heat from the here, heat from the source. Okay, developing work as output and rejecting some amount of heat. जेवढं हीट वर्क सप्लाय केलं ती वजा करून जेवढं राहते तेवढं रिजेक्ट. कुठे रिजेक्ट करतं तर लो टेम्परेचर बॉडी, ती म्हणजे काय असतं? ऍटमॉस्फिअर. एव्हरीबडी अंडरस्टँड हीट इंजिन? चॅट बॉक्स or if yes sir, Prathamesh, yes sir, okay. Pawan, Prathamesh, Prerna, Vankade, yes, okay. Now to define the performance of heat engine, which term we are using? Anybody? Which term we are using? Anybody of you? It is called what? Efficiency of a heat engine. So what is that? Efficiency of a heat engine. So efficiency of heat engine is always in the form of what? 30% to 40%. And how we define efficiency? Efficiency of a heat engine is defined as eta. Symbol for efficiency is what? Eta, mathematical symbol, is equal to what? Output upon input. What is output? Work obtained. What is that output? Is what? Work generated or work obtained. I will write only work. You should write work output. Okay, or work output divided by input is what? Heat input. So this is what called as efficiency of a heat engine. How we can define? Write in our notebook. So don't consider 10 as 500. So it is, for example, they have given. Okay. So source means at high temperature. That is our definition with it. For and to understand that, they have given the temperature as 500. So work output. What is the work output? It is W divided by heat input is Q1. But W is equal to what? Q1 minus Q2 by definition, by balancing, by divided by Q1, and is equal to what? 1 minus Q2 upon Q1. म्हणजे काय आता आपल्याला? It is what? Efficiency of heat engine. So I can write here efficiency of heat engine. How we define efficiency of heat engine? Anybody? It is the ratio of work obtained from the engine to the heat supplied. Okay, and is equal to what? W. Work obtained is what? W, and heat supplied is Q1, W upon Q1, but in terms of W you can write in terms of heats. Okay, heat rejected and heat supplied. So Q1 heat supplied minus heat rejected divided by Q1 is equal to 1 minus Q2 upon Q1. What this is mathematical relation? काय ह्याच्यातून काय तुम्ही अंडरस्टँड करता सांगा बरं. Heat efficiency of heat engine is 1 minus Q2 upon Q1. बघू कोणी कोणी अभ्यास केलाय बीएमईचा व्यवस्थित, कोण सांगते कन्फ्युजन.
Of heat engine is never equal. It is
Never equal to 1 or 100%. No heat engine is having 100% efficiency. म्हणजे काही अमाऊंट ऑफ हीट, सम अमाऊंट ऑफ हीट दॅट हीट इंजिन हॅव टू रिजेक्ट टू द ॲटमॉस्फिअर. Q2 अमाऊंट काहीतरी आहे व्हॅल्यू, म्हणजे ती रिजेक्ट केली पाहिजे जाते. आणि म्हणून कोणत्याही हीट इंजिन, देर इज नो हीट इंजिन इन द वर्ल्ड is having 100% efficiency. Some amount of it always it have to reject to the surrounding. So 1 minus Q2 upon Q1. Okay, so but all amount of it never convert into work. Very good, Prathamesh, very good. Means no if is याचा दुसरा अर्थ काय, all amount of it can never convert into work. Means what? Here another meaning is that here no heat engine is having 100% efficiency, or no heat engine having 1 percentage नको असेल तर आपल्याला 1 efficiency. Okay, means but to have the maximum efficiency of a heat engine, what we have to do, काय केलं असलं पाहिजे सांगा बरं कंडिशन. एकच्या जवळ असण्यासाठी काय पाहिजे, हीट रिजेक्टेड काय पाहिजे, जेवढी कमी पाहिजे. इकडे ही क्वांटिटी काय पाहिजे, लेस, म्हणजे काय पाहिजे, ही Q2 should be, heat rejected should be as minimum as possible, and Q1 heat supplied should be as maximum as possible. म्हणजे हाय जेवढं हाय टेम्परेचर जास्त तेवढी तुमची हीट काय सप्लायड जास्त, जेवढं तुमचं हीट रिजेक्शन टेम्परेचर जेवढं कमी तेवढं तुमची इफिशियन्सी जास्त. म्हणजे efficiency जास्त असण्यासाठी to have the maximum efficiency of heat engine, what should be, what is condition here, heat rejected should be as less as possible and heat supplied should be as more as possible. Will you understand about heat engine? Okay, so we'll go to another our class notes. Okay, heat engine, it is cyclic operating device whose sole effect is to develop work. For heat engine, input is heat, Q, and output is work. Okay, so block diagram is there. Q1 W is amount of work. Okay, then heat work efficiency of heat engine is given by and is defined as ratio of work obtained from heat engine to heat input supplied to it. Work obtained divided by heat supplied. Therefore, eta is equal to W upon Q1. But from figure, W is equal to Q1 minus Q2. Incoming is equal to outgoing. Okay. So Q1 minus Q2 upon Q1. 1 minus Q2 upon Q1. For getting maximum efficiency, all heat engine of heat engine, heat supplied should be as more as possible. म्हणजे काय, जेवढी जास्त जेवढी पाहिजे, and here heat and heat rejected should be as low as possible. Okay, सगळ्याला heat engine efficiency, heat engine म्हणजे काय समजलं सगळ्याला, because this is basic for us, and याच्यावर numerical, we have to solve the numericals on this, and afterwards definitely some complicated equations etc. we have to develop. So the basic, if you understand, there will be no problem henceforth to understand other subjects also there, refrigeration and air conditioning, heat transfer. This is the basic for that. Chat box, please reply so that we can go for next device. I am taking this as a very slowly because this is very much important. Yes, understand phones in the Smita Sarvadi, yes sir. Others please reply fast. Ganesh Gauli, yes sir. Okay, good. Yes, sir. Go to next. Very good, Prathamesh. Yes, sir. Okay. Now next device. Pradeep Dumal. Okay, good. Next device is okay. Heat engine efficiency is what? 100, not 100%, 30 to 40%. Now another device is called as what? Refrigerator. Another device is called as what? Refrigerator. So what is refrigerator? So refrigerator is what? It is the device here which takes work as a input. म्हणजे refrigerator is taking work in as a input, and what it is doing, work as the input and taking heat from low temperature body, taking heat from low temperature body. म्हणजे जी बॉडी आपल्याला गार कूल करायची आहे ती नेहमी काय ह्याची असते, लो, त्याचं टेम्परेचर काय करतं, ते कमी कमी करतं इव्हॅपरेटर. ते असली गोष्ट काय असते इव्हॅपरेटर, तर त्याचं टेम्परेचर कमी असतं आणि त्याच्यातूनच हीट घेतं. म्हणजे लो टेम्परेचर कडून काय करतं, ते हीट ऍब्सॉर्ब करतं आणि कुठं सोडतं, ते हाय टेम्परेचर बॉडीला. म्हणजे हीट इज टेकिंग फ्रॉम लो टेम्परेचर बॉडी, सिंक कडून घेते लो टेम्परेचरला आणि इट इज सप्लाइंग टू high temperature bodies. But we know that here there is heat will not flow from low temperature body to high temperature body, but it have to supply some external work. Therefore work is supplied in the for to the compressor. Okay, and so this is the refrigerator means evaporator. Okay, so this is a evaporator. आता आपण refrigerator इमॅजिन करा. आता इन साइड युअर रेफ्रिजरेटर एक आहे आपल्या घरात, म्हणजे सगळ्यांच्या आहे, एव्हरीबडीज होम दॅट रेफ्रिजरेटर इज दॅट. सो इनसाइड बॉडी इज व्हॉट, इनसाइड बॉडी इज कॉल्ड एज their cooling is obtained. Inside body there is what, cooling is obtained. So that is called as evaporator. त्याच्यापासून एक त्या रेफ्रिजरेटरच्या बॉडी मधून काय केले असते, कॉइल्स सप्लाय केलेले असते. refrigerant is passing to it and the refrigerant is having temperature at low temperature. refrigerant तर पहिली प्रॉपर्टी काय असते, at low temperature they evaporate. okay, means they will evaporate and त्याला जी evaporation साठी लागणारी जी हीट आहे ती त्या आतमध्ये ठेवलेले जे आपले पदार्थ आहेत त्या पदार्थाकडून ते काय करतं, हीट घेतं आणि रेफ्रिजरंट तिथं काय होतं, इव्हॅपोरेट होतं. आणि इव्हॅपोरेट झालेलं रेफ्रिजरंट काय होतं, हीट काढून घेतं त्या सबस्टन्स मध्ये सगळ्या. तुम्ही भाजी ठेवचाल, दूध ठेवचाल, एनिथिंग यू आर गोइंग टू टेक. ओके, तर तिथं काय होतं, तुमची हीट इज गोइंग टू बी रिमूव्ड फ्रॉम दॅट पर्टिक्युलर ऑब्जेक्ट्स. ओके, और atoms, food atoms. okay, and that refrigerant is what, liquid refrigerant is what, converting into vapor refrigerant. Afterward that vapor refrigerant is passed to compressor. आणि कॉम्प्रेसर काय करतो, ते रेफ्रिजरंट कॉम्प्रेस करतो, त्याचं काय करतो, प्रेशर वाढवतो आणि ते रेफ्रिजरंट काय जातं, कंडेन्सरला सप्लाय केलं जातं. कंडेन्सर व्हॉट इट इज डुईंग, so whatever the vapor refrigerant is there, so that vapor refrigerant is what, converting into again liquid refrigerant. इथे काय करतं, ते अगेन लिक्विड रेफ्रिजरंट. हे लिक्विड रेफ्रिजरंट काय करतं, थ्रोटल वॉल मधून जातं, त्यातील काही रेफ्रिजरंट हे इव्हॅपोरेट होतं, काही लिक्विड रेफ्रिजरंट पुन्हा रेफ्रिजरेटर मध्ये जातं, पुन्हा ते काय करतं, पुन्हा ते हीट घेतं लिक्विड रेफ्रिजरंट आतमधले काढून, स्वतः इव्हॅपोरेट होतं, पुन्हा ते इव्हॅपोरेट झालेलं पुन्हा ते कॉम्प्रेसरला सप्लाय केलं जातं. कॉम्प्रेसर त्याचं हाय प्रेशर मध्ये रूपांतरित करतं त्या रेफ्रिजरंटला. म्हणजे आपला फक्त उद्देश काय, त्या बॉडी मधली हीट काढून घ्यायची. जे पदार्थ आपण ठेवणार त्याच्यातली हीट काढून घेतली की ते पदार्थ काय राहतात, थंड किंवा कूल राहतात. ओके, इनसाइड बॉडी, आता आपल्याला काय करतं, इनसाइड बॉडी ऑफ रेफ्रिजरेटर इट ऍक्टिंग ॲज अ इव्हॅपोरेटर. म्हणजे इव्हॅपोरेटर ती सगळी बॉडी नाही, पण त्याच्या आतून कॉइल आहे, त्या ह्याच्या सगळ्या त्या रेफ्रिजरेटरची बॉडी असते त्याच्यामध्ये कॉइल फिरलेले असते आणि त्या कॉइल मधून ते रेफ्रिजरंट काय करतं, हीट सगळी त्या स्पेस मधली काय करतं, ऍब्सॉर्ब करतं. म्हणजे ती बॉडी कूल केली जाते. इनसाइड पोर्शन इज गोइंग टू बी फ्रॉम दॅट हीट इज गोइंग टू बी टेकन फ्रॉम द रेफ्रिजरंट. नंतर इट इज कॉम्प्रेसर. तर मी रेफ्रिजरेटरच्या जर मागच्या साईडला बघितलं तर एक कॉम्प्रेसर असतो, छोटासा गट्टू असतो, तो त्याला हार्मॅटिकली फील्ड कॉम्प्रेसर खाली असतो. बघितलं, आठवते जरा थोडं इमॅजिन करा. ओके. आणि तो कॉम्प्रेसर वर्क त्याला सप्लाय केला जातो. तो कॉम्प्रेसरला आपण इलेक्ट्रिक इनपुट दिलेलं असतं, म्हणजे इलेक्ट्रिकल इनपुट इज गिव्हन टू कॉम्प्रेसर अँड दॅट इज कन्व्हर्टेड आफ्टरवर्ड्स इनटू मेकॅनिकल वर्क. ओके. तर कॉम्प्रेसरला वर्क दिलं जातं, त्यामुळे ते कॉम्प्रेसर पंप करतं ते वेपर रेफ्रिजरंट, आणि जेवढं ते पंप करेल वेपर रेफ्रिजरंट तेवढं त्यातलं काय होईल, ते गार, थोडं गार होईल. आणि नंतर ही जास्त हीट असलेलं कॉम्प्रेसर नंतर जी हीट वाढते, कंडेन्सर हा मागच्या साईडला जी ब्लॅक पोर्शन असतं, ब्लॅक ग्रीड असते, ग्रीड जाळीसारखे जे स्ट्रक्चर आहे ब्लॅकला, ते असतो, तो काय असतो, कंडेन्सर. कंडेन्सर मध्ये काय झालं तर हीट रेफ्रिजरंट मधल्या, आता रेफ्रिजरंट ऍब्सॉर्ब केलेली हीट आहे स्पेस मधली, ती हीट काय करतं कंडेन्सर बाहेर फेकून देतं, आणि वेपर रेफ्रिजरंटचं काय करतं, लिक्विड रेफ्रिजरंट मध्ये रूपांतर करतं. आणि त्यामुळं जर तुम्ही बघितलं तर रेफ्रिजरेटरच्या जर तुम्ही मागच्या साईडला जर उभा राहिला तर व्हॉट विल फील, ओके, संदीप ठावरेचा एक प्रश्न आहे. ओके, हॉट वेपर, करेक्ट, हॉट वेपर नाही, हॉट वी आर फिलिंग हीट हॉट. कारण काय करतं कंडेन्सर, काय जेवढी हीट त्यानं घेतलेली असते तेवढी हीट काय करतं, ते रिजेक्ट करतं. देअरफॉर दॅट पोर्शन इज सीम्ड टू बी व्हेरी हॉट बिहाइंड दॅट कंडेन्सर. तिथं लिक्विड रेफ्रिजरेटर होतं, पण सायकल असं कंटिन्यू चालू राहतं. ह्या पोर्शनला, ह्याला काय म्हणायचं आपण, रेफ्रिजरेटर. म्हणजे इथं इनपुट काय आहे तर वर्क, यू आर गेटिंग. म्हणजे वर्क जर नसेल तर लो टेम्परेचर बॉडी कडून हाय टेम्परेचर बॉडी कुठल्या येतं, ऍटमॉस्फिअर. कुठे आपण हीट रिजेक्ट करतो, ऍटमॉस्फिअरला, रूम मध्ये रिजेक्ट करतो. त्यामुळे ऍटमॉस्फिअर इज ऍक्टिंग ऍज ए हाय टेम्परेचर बॉडी, आणि हिअर रूम इज ऍक्टिंग ऍज ए रेफ्रिजरेटर की स्पेस इज ऍक्टिंग ऍज ए लो टेम्परेचर बॉडी, म्हणजे सिंक रेफ्रिजरेटर झाला. ऍटमॉस्फिअर काय झाला, हिअर इज गोइंग टू बी सोर्स झाला याच्यामध्ये. ओके. याच्यामध्ये जर आपण डायग्रामॅटिकली रिप्रेझेंटेशन केलं, ओके, तर इथं आता वॉर्म टेम्प एन्व्हायरमेंट, म्हणजे इथं काय झालं, वॉर्म एन्व्हायरमेंट म्हणजे तुमचा हीट डायग्राम इव्हॅपोरेटर म्हणजे स्पेस. ओके. इथून कॉम्प्रेसर दिलं जातं, कॉम्प्रेसर कंडेन्सर असे, दिस इज गोइंग टू बी डायरेक्शन. इथून लिक्विड रेफ्रिजरंट येतं आतमध्ये इव्हॅपोरेटरच्या आधी, ते काय करतं इथं, इथं वेपर, म्हणजे त्याला लिक्विड टू वेपर, म्हणजे त्याला हीट लागणार. हीट कुठून घेतं तर त्या जे सबस्टन्स आतमध्ये ठेवलेत आपण त्या स्पेस मध्ये, तिथून घेतं ते. ओके. स्वतः लिक्विडचं रूपांतर काय होतं, वेपर मध्ये होतं, आणि वेपर इज पास्ड टू द कॉम्प्रेसर. कॉम्प्रेसरला वर्क आपण सप्लाय करतोय इथं, म्हणून इथं का एरो कसा आहे आपला, वर्क इनपुट डब्ल्यू इन रेफ्रिजरेटर, आणि रेफ्रिजरेटर स्पेस मधून आपलं हे टेम्परेचर आहे, म्हणजे रेफ्रिजरेटर स्पेस आतली, हे झाला तुमचा सिंक. आपल्या भाषेमध्ये जर बोलायचं तर हा काय झाला, आपला सिंक झाला, लो टेम्परेचर काय असेल ते, आणि तुमचं हा काय झाला, सोर्स झाला. एन्व्हायरमेंट काय झाला, एन्व्हायरमेंट म्हणजे तिकडं आपण बाहेर रूम मध्ये आपण काय करतो, हीट आपण सप्लाय करतो. दिस इज बी ऍक्टिंग ऍज ए सोर्स, दिस इज ऍक्टिंग ऍज ए सिंक. रेफ्रिजरेटर टेकिंग वर्क ऍज ए इनपुट and taking heat from low temperature sink or low temperature body and supplying to high temperature body by taking help of work. So and here इथं जेवढं तुमचं जेवढी हीट जेवढी घेईल, ते काढून घेईल त्या सबस्टन्स मधून, तेवढं तुम्हाला कुलिंग तिथं जास्त मिळणार. तर एक वाटते रिव्हर्स ऑफ हीट इंजिन. Reverse of heat engine we can say. Okay. Now here one question is asked by, so that my students should not remain question. Sir, how to increase engine efficiency? तर कशी सांगितली इंजिन एफिशियन्सी, फॉर्म्युला आपला इंजिन एफिशियन्सीचा. हिअर व्हॉट इज इंजिन एफिशियन्सी फॉर्म्युला आय टोल्ड. संदीप सावरे, आर यू इन लिसनिंग? इंजिन एफिशियन्सी फॉर्म्युला काय सांगितला, कशी वाढवायची एफिशियन्सी? इंजिन एफिशियन्सी वाढवण्यासाठी आपण काय केलं पाहिजे, समबडी इज टेलिंग. आय थिंक सम गर्ल स्टुडंट इज टेलिंग, एम आय राईट? supply heat means supply increase heat. Okay, increase in supply in heat आणि heat rejected to be काय कमी झाली पाहिजे. म्हणजे engine efficiency if you want to increase, then heat rejected should be as low as possible and supply maximum heat. Heat should be supplied maximally. Then we say that efficiency of engine will be increased. म्हणजे heat supply जास्त वाढवा आणि heat rejected काय केली पाहिजे कमी केली पाहिजे. मग we can get the engine more engine efficiency. Am I clear now? It is clear to Thavre, Sandeep ji?
Yes, yes.
I think you are I think net internet connection is not proper. You can chat. Sandeep ji, your question, your query is over, so that we can proceed to next. So my students' query should not be there. That is my always intention. स्टुडंटची क्वेरी राहायला नको आणि पाठ करायला नको कुठला भाग, म्हणून मी सांगतो एवढं तुम्हाला बेसिक. संदीप जी, तुमच्यामुळे थांबले आम्ही सगळे. You have to reply fast. Asmita could try to explain, huh? Okay, Sandeep ji was yes, understood. Okay, very good. Thank you, Sandeep. Okay, now here we have to go for performance of a refrigerator. And performance of a refrigerator काय असणार आहे? What is the definition of performance? Here also output divided by input. What is output? But here amount of heat taken. Heat taken झाली म्हणजे CO. That is called as what? COP. तर आपण काय केलं, जर आपण हीट ऍज ए इनपुट घेतलं म्हणजे इंजिन सारखं जर केलं तर त्याची इफिशियन्सी काय होईल 100 पेक्षा जास्त होईल. ओके, समजा इफिशियन्सी इंजिनची 1/0.30% म्हणजे 0.3 आहे, तर 1/0.3 वॉट मोर दॅन 1. म्हणून इंजिनची रेफ्रिजरेटरचा परफॉर्मन्स हा इफिशियन्सी मध्ये काढत नाही. तर तो कसा काढतात? इट इज गोइंग टू बी कॅल्क्युलेटेड इन टर्म्स ऑफ कोएफिशिएंट ऑफ परफॉर्मन्स. It is calculated in the form of what? Coefficient of performance. Okay, so how, what is coefficient of performance? Here आता इथं आपलं बॉडी, तर कोएफिशिएंट ऑफ परफॉर्मन्स म्हणजे काय? Here it will nothing but here amount of heat, it is ratio of amount of heat removed by the refrigerator. कुठून केवढी हीट रिमूव्ह केलेली आहे? Q2 एवढी. ओके, आणि त्याचं इनपुट काय आहे? ओके, इनपुट काय? W. So output divided by input. Output काय? How much amount of it is taken? Okay, from that space, जास्त कमी स्पेस मधून, आणि वर्क ऍज ए इनपुट Q2 upon W. बट और रिजेक्टेड म्हणजे Q2 ला काय म्हणते ते हीट रिजेक्टेड, त्याला हीट सप्लाइड और पास सप्लाइड. Therefore it will be what? Here Q2 upon W. बट Q2 आता आपल्याला W काढायचा आहे, तर काय इनकमिंग इज इक्वल टू आउटगोइंग. आता इथे इनकमिंग काय काय आहे? Q2 ऍज ए इनकमिंग, W पण काय तुमचा इनकमिंग, आणि आउटगोइंग काय Q1. इथे बघा Q2 Q1 एरो महत्वाचे आहेत. ओके, इट इज Q1. ओके, एरो इज व्हेरी प्लेइंग. जर तुम्ही हा एरो केला असा केला तर काय होईल? हीट इंजिन. हियर इट इज रेफ्रिजरेटर, इट इज नॉट हीट इंजिन. It is what? Exactly reverse of refrigerator, but it should be called as what? Refrigerator. Okay, refrigerator, REF you can write. So इथं जर तुम्ही जर एरो जर असा दाखवला, हीट इंजिन होणारच नाही ते, कारण हीट इंजिन काय करते? डेव्हलप होतं वर. तर याचा अर्थ W जर असं दाखवला तर मग ते हीट इंजिन होईल. ओके, आणि एरो सगळे बदलतील. So Q2 plus W is equal to Q1. Okay, therefore W is equal to what we can say? Q1 minus Q2. And therefore Q2 is what? Is equal to what? Q2 divided by W is what? Q1 minus Q2. This is what? COP of a refrigerator. Everybody understand? Everybody understand? Please reply. Yes, sir. Yes, sir. Okay. So COP of refrigerator is given by what? Q2. कारण जेवढी हीट त्यानं रेफ्रिजरेटर स्पेस मधून जेवढी घेतलेली आहे, that is nothing but Q2 divided by W. Okay. Work input as a this is input and here output will be किती हीट त्यानं घेतली तेवढं त्याचं coolness आपल्याला जाणवणार. Okay. So Q2 divided by W is nothing but the efficiency coefficient of COP of a refrigerator. Everybody understand this refrigerator? We'll go for the class notes. No, refrigerator. It is what? Here notes तुम्हाला वापरायचे आपल्याला. Okay. It is cyclic operating device whose sole effect is to extract heat from a body at low temperature. जेवढं low temperature body कडून किती heat absorb करेल तेवढी heat. Okay. The block diagram. A refrigerator RE the work as a देतोय इथं ते तुम्ही arrow जर चुकीचा काढला W जर इकडून काढला असा तर इट इज व्हॉट रॉंग. Q1 Q2 त्यानं घेतलेले आहे सिंक कडून. सिंक म्हणजे तुमचं काय झालं रेफ्रिजरेटर स्पेस आणि सोर्स काय झाला ऍटमॉस्फिअर. रिजेक्ट कुठं करतो आपण ऍटमॉस्फिअरला रूम मध्ये आपण ऍटमॉस्फिअर म्हणतो. ओके. Q1 COP of performance it is defined as ratio of amount of heat extracted from body. Okay, low temperature body म्हणा किंवा body to the work input supplied. So COP heat extracted divided by work input. Therefore Q2 divided by Q1 minus Q2. One equation value. Now another device is called as what? Heat pump. काय म्हणणार आपण heat pump ला? समर्थ and Tanaji, this is 2-hour lecture. Don't write your roll numbers for attendance purpose. If you want to interact in the form of giving answers, whatever I am asking in between. Anybody? हीट पंप म्हणजे काय असणार सांगा बरं. हीट पंप आणि काय असणार? हीट पंप काय असणार हीट पंप? एनीबडी तुमच्या भाषेत सांगा म्हणजे आय कॅन somebody can chat or somebody can unmute and tell what is heat pump. काय तुम्ही शिकला heat pump BMA मध्ये? Anybody of you? Anybody of you can tell? Chat box, I got an answer. Pump heat towards output from input. It transfer heat from cold to hot. Okay. Good. Pump heat towards output from input. Okay. Definition okay, but still you are trying. Understood? Okay. So heat pump is what? It should be what that space we have to heat, and we have to maintain the temperature of space more than atmosphere. म्हणजे हीट पंप जर थंडीमध्ये आपण वापरतोय तर थंडीमध्ये काय असतं ऍटमॉस्फिअर हे काय असतं बाहेरचं कूल असतं टेम्परेचर काय असतं कमी असतं आणि आपल्या रूमचं टेम्परेचर आपण काय करतो वी आर मेंटेनिंग मोर. म्हणजे ऍटमॉस्फिअर मधली लो टेम्परेचर ऍटमॉस्फिअर आहे. ओके. तिथून हीट सगळी एक्स्ट्रॅक्ट करायची ऍटमॉस्फिअर मध्ये. आपल्याला ऍटमॉस्फिअर मधले किती जर थंडी पडली तर आपल्याला नको आहे काय घेणं देणं नाही. आपली जी रूम सिस्टीम आहे थर्मोडायनामिक आपली रूम तेवढी काय झाली पाहिजे आपली हॉट झाली पाहिजे. आपण काय करतो ऍटमॉस्फिअर मधली जेवढी हीट आहे दॅट लो टेम्परेचरला तेवढी हीट आपण काय करतो रूम मध्ये आणतो. रूम मध्ये सप्लाय करतो, जेणेकरून रूमचं टेम्परेचर काय होईल, वाढेल. ओके, तर दॅट विल बी कॉल्ड एज व्हॉट, हीट पंप. ओके, टेम्परेचर ओके तेवढंच राहील, पण इट विल बी वी आर फिलिंग द हिटिंग, म्हणजे ऍटमॉस्फिअर तिथं लो टेम्परेचरला जातं आणि रूम आपली काय झाली, हाय टेम्परेचर झाली. म्हणजे सप्लाइंग हीट, हाऊ मच अमाऊंट ऑफ, म्हणजे रेफ्रिजरेटर आणि हीट पंपची ब्लॉक डायग्राम सारखीच आहे. रेफ्रिजरेटर आणि हीट पंपची ब्लॉक डायग्राम इट विल बी व्हॉट, सेम. There is no difference in the block diagram. Block diagram will remain what, same. But here purpose काय, इथं रेफ्रिजरेटरचा ह्याचा हीट पंपचा purpose is what, here some books have written RE oblique heat pump. इथं काय, जेवढी हीट एक्स्ट्रॅक्ट करतो तेवढा थंडावा मिळतोय. आणि इथं काय, सोर्स, म्हणजे इथं सोर्स काय झाली आपली, रूम झाली आपली सोर्स, आणि सिंक झालं तुमचं ऍटमॉस्फिअर. आणि रेफ्रिजरेटर मध्ये काय उलट आहे, रेफ्रिजरेटर मध्ये काय असणार आहे तुमचं, सोर्स म्हणजे ऍटमॉस्फिअर आणि सिंक म्हणजे तुमची स्पेस. ओके, तर इथं काय, जेवढी हीट तुम्ही सप्लाय करताय सोर्सला, दॅट इज द एक्स्ट्रा आउटपुट. तुम्ही जास्तीत जास्त हीट तुम्ही सप्लाय करताय इथं, आणि रेफ्रिजरेटरला जेवढी हीट एक्स्ट्रॅक्ट करताय, काढून घेताय, आणि तर जेवढी हीट तुम्ही त्या सोर्सला थर्मल रिझर्वायरला सप्लाय करताय, तेवढी त्याचं काय असणार तुमचं आउटपुट. आणि इनपुट तर नेहमी वर्क असणार आहे. तर सीओपी ऑफ हीट पंप म्हणजे काय असणार आहे, इट इज व्हॉट, तीच डायग्राम असणार आहे हीट पंपची पण काय, इट इज डिफाइंड एज रेशिओ ऑफ अमाऊंट ऑफ हीट supplied to high temperature body, to the work input supplied, म्हणजे जेवढी हीट तुम्ही सप्लाय करताय त्या हाय टेम्परेचर बॉडीला, सोर्सला, that divided by the work input, so that ratio is called as COP of your heat pump. Therefore heat supplied to work input, आणि तिकडे heat extracted divided by work input. पर्पज फक्त लक्षात ठेवा, पर्पज रेफ्रिजरेटरचा जेवढी हीट ऍब्स्ट्रॅक्ट करणे, जेवढी हीट ऍब्स्ट्रॅक्ट करेल तेवढं तिथली बॉडीचं स्पेस काय होईल, ते कुलिंग होईल, आणि तिथलं टेम्परेचर काय होईल, त्या आतमधलं कमी होईल, कॉन्स्टंट राहील पण कमी होईल. आणि सोर्स मधलं काय, तर इथलं टेम्परेचर तुमचं काय होईल, जेवढी हीट तुम्ही सप्लाय कराल तेवढं सोर्सचं टेम्परेचर काय होईल, इट विल इन्क्रीज. ओके, और विल फील हीटनेस. ओके, सो हीट सप्लाय टू द वर्क इनपुट. सो इथं काय, Q1 divided by W. तर W पुन्हा एकदा Q1 minus Q2 देतोय, Q1 divided by Q1 minus Q2. Okay. Now this is called as COP of heat pump. Q1 divided by Q1 minus Q2. Now from 1 and 2 relation, COP of heat pump is given by. आता काय करायचं याच्यामध्ये, रेफ्रिजरेटरचा COP of refrigerator is given by Q2 divided by Q1 minus Q2. आपण वाईस केले, extracted divided by work म्हणजे Q1 minus Q2. heat supplied minus heat rejected. दोन्ही बाजूला एक we have adding 1 on both sides. दोन्ही बाजूला जर एक साइड आपण 1 ऍड केलं तर काय होईल, 1 plus COP of refrigerator is equal to 1 plus Q2 upon Q1 minus Q2. हे केलं तर काय होईल, Q1 minus Q2 प्लस Q2, म्हणजे इथे काय होईल तुमचं, एक Q2 आणि Q2 प्लस आहे, इकडे जाणार Q1 काय Q2 मायनस, ते विल इट विल गेट कॅन्सल, अँड इट विल व्हॉट, Q1 डिवायडेड बाय, याचं उत्तर काय होईल, याचं Q1 डिवाइड बाय Q1 मायनस Q2. म्हणजे दिस इज काय, Q1, दिस इज नथिंग बट Q1 COP of heat pump. Therefore COP of refrigerator is equal to 1 plus COP of refrigerator is equal to COP of heat pump, or COP of heat pump is equal to 1 plus COP of refrigerator. Understand? Please mention in chat box. काय अडचण असेल तर विचारा. Understood? Understood. Asmita Sarvari, yes. Pratami Sarangi, yes, sir. Good. Pon Sindhi, yes. Okay. So getting now heat pump transfer heat from a low temperature medium to high temperature medium. Low temperature पासून high temperature low temperature म्हणजे इथं काय atmosphere आणि ही term ची heated space. Okay. Heat pump W arrow कसा आहे इकडे arrow because work is given to heat pump. त्याशिवाय ते इथली हीट घ्यायची आणि इथं टाकायची आणि इथं काय करायचं इथली हीट घेऊन इथं टाकायची पण इथं ही स्पेस हे जे इथं आपल्याला हा हिटेड स्पेस इज आवर थर्मोडायनामिक सिस्टम रेफ्रिजरेटरला जेवढं हीट आपण काय करतो ऍब्सॉर्ब करतो दॅट विल बी आवर thermodynamic system. Okay, so heat pump transfer heat from a low temperature medium to high temperature medium. Refrigerators and heat pumps are essentially the same devices. They differ in their objective only. दोन्ही सेम आहेत बॉल डायग्राम फक्त ऑब्जेक्टिव्ह त्यांचं वेगळा आहे एखादा ऑब्जेक्टिव्ह हीट एक्सट्रॅक्ट करणं एका दुसऱ्या ऑब्जेक्ट हीट सप्लाय करणं. Refrigerator is to maintain the refrigerator space at low temperature. On the other hand, it absorbs heat from a low temperature source and supplies the heat to a warmer medium. In a heat pump, desired effect is amount of heat supplied Q1 to the space being heated. So heat supplied by the heat pump Q1 divided by W, Q1 divided by Q1 minus Q2. And here's 1 plus Q1 2 upon 1 plus Q2 divided by Q1 minus Q2. Q2 divided by Q1 minus Q2 काय असतं COP of refrigerator किंवा COP उलट जाऊ शकतो आपण COP ला याच्यामध्ये 1 केल्यानंतर COP of refrigerator plus 1 is equal to COP of heat pump. The COP of heat pump operating as a heat pump is always higher than the COP of same machine operating as a refrigerator by unity. म्हणजे रेफ्रिजरेटर आणि एकच टेम्परेचर जर ते सेम असेल आणि रेफ्रिजरेटरचा सीओपी आणि रेफ्रिजरेटर हीट पंपचा सीओपी याच्यामध्ये डिफरन्स असतो तो युनिटीचा 1 चा डिफरन्स नेहमी असतो. So this is not performance refrigerator एनर्जी एफिशिएंट असावं. ओके ते आपल्या सिलेबस नाही. नाउ सेकंड लॉ ऑफ थर्मोडायनामिक्स केल्विन प्लॅंक स्टेटमेंट. आता हे आपण झाल्यानंतर केल्विन प्लॅंक स्टेटमेंट आणि आपल्याला Kelvin Planck statement and you can say here another is Clausus statement. पहिल्यांदा लक्षात ठेवायचं Kelvin Planck statement is always related to engine. Kelvin Planck statement is related to engine. Kelvin Planck statement is related to engine आणि Clausus statement is related to anybody. Kelvin Planck statement is related to heat engine only and Clausius statement is related to only anybody chat box or you can unmute. Efficiency Clausius statement nahi prerna ji wrong. It is related to refrigerator and COP of refrigerator and heat pump. So Clausius statement is related to heat pump and refrigerator and Kelvin Planck statement is related to heat engine. Everybody getting? Kelvin Planck हा heat engine साठी वापरलं जातं. हे कधी जम्बलिंग करायचं नाही आणि Clausius statement is related to refrigerator and heat pump machines. Okay. तर काय Kelvin Planck statement? It is impossible for a system to operate in thermodynamic cycle and deliver a net amount of work to its surrounding while receiving an energy transfer by heat from a single thermal reservoir. Okay, or it is impossible for any device that operates in a cycle to receive heat from a single reservoir and produce net amount of work or equivalent work. म्हणजे जेवढी amount of Q1 amount of Q1 it is impossible to construct a cyclic operating device whose sole effect is to transfer equal to transfer all amount of heat supplied into an equivalent work So we'll go to our class notes first so that that definition henceforth. हे आपले काय टर्मचं इट इज इम्पॉसिबल टू कन्स्ट्रक्ट ए सायक्लिक डिव्हाइस ऑपरेटिंग डिव्हाइस whose sole effect is to transfer all amount of heat into an equivalent work. काय असा कुठलाही डिव्हाइस नाहीये इट इज इम्पॉसिबल असं काय म्हणतो केल्विन प्लॅन इट इज इम्पॉसिबल टू कन्स्ट्रक्ट ए सायक्लिक ऑपरेटिंग डिव्हाइस सायक्लिक ऑपरेटिंग असणारा असा कोणताही डिव्हाइस नाहीये की ज्याचा एक काय असेल फक्त पर्पज काय असेल जेवढी हीट सप्लाय केली जाते तेवढी अमाऊंट ऑफ वर्क ऑप्टेन करणं असं कुठल्याही डिव्हाइसला शक्य नाही किंवा नो हीट इंजिन इज हॅव्हिंग 100% इफिशियन्सी सो दॅट इज कॉल्ड एज व्हॉट Kelvin Planck statement. Everybody getting? So write down Kelvin Planck statement. Need diagram पण काढा. I will give 5 minutes to you. Because very important. This is very Kelvin Planck statement. हेच statement आपल्याला परीक्षेत लिहायचं स्टेट सेकंड here Kelvin Planck statement. It related to engine. Kelvin Planck statement is related to इंजिन ह्या वाटलं इट इज रिलेटेड टू इंजिन याच्यामध्ये फक्त इंजिनची इफिशियन्सी आणि इंजिन एवढे शब्द येणार आहेत इट इज इम्पॉसिबल टू कन्स्ट्रक्ट ए सायक्लिक ऑपरेटिंग डिव्हाइस whose sole effect म्हणजे तेवढाच sole effect is to transfer all amount of heat into an equivalent work or no heat engine is having 100% efficiency. Source temperature T1, Q1, HE, heat engine W. If it is write up is over, then tell me. Over, tell me. Completed, Abhishek Dada, good. Now to reply if I will get, I will continue. Abhishek Zadu completed, others please reply. Beginningly completed, good, over, okay, good. So this is our Kelvin Planck. Now another statement means what? Q2, Q1 cannot be equal to W. म्हणजे याच्यामध्ये काय Q1 cannot be W. जेवढी amount of heat हे जर आणि Q2 should not be equal to 0. Q2 जर 0 झाला तर Q1 is equal to W होत आहे. Q1 is equal to W साठी सेकंड कंडिशन काय पाहिजे? There should be heat rejected. काहीतरी amount of heat should be rejected from the थर्मल रिझर्वायर. म्हणजे Q2 जर 0 झाली तर फक्त हीट इंजिन आपला एकाच थर्मल रिझर्वायर बरोबर इंटरॅक्ट करेल. ते पण बरोबर नाही. म्हणजे नो हीट इंजिन विल रिॲक्ट विथ ओनली वन थर्मल रिझर्वायर. इट हॅव टू इंटरॅक्ट विथ बोथ thermal reservoir, that is source and sink. Both thermal reservoirs you have to reach. Okay. Now another statement is what? Clausius statement. It is related to Clausius means what? It is related to only heat pump and refrigerator. Clausius चा heat pump आणि refrigerator ची संबंध आहे. It is not having relation with to heat engine. Okay. Clausius statement. It is impossible to construct a cyclic operating device like refrigerator or heat pump which can transfer heat from low temperature body to high temperature body without consumption of external work. म्हणजे एक्सटर्नल वर्क घेतल्याशिवाय कुठल्याही डिव्हाइस तयार करणं शक्य नाही की जो लो टेम्परेचर बॉडी कडून हीट काय करेल, हाय टेम्परेचर बॉडीला सप्लाय करेल. असा कोणताही सायक्लिक ऑपरेटिंग डिव्हाइस तयार नाही. Okay? It is impossible to construct a cyclic operating device, that is refrigerator or heat pump, which can transfer the heat from low temperature body to high temperature body without consumption of external work. म्हणजे फक्त एक्सटर्नल वर्क जर दिलं तरच आपण लो टेम्परेचर कडून हाय टेम्परेचर कडे हीट आपण सप्लाय करू. ओके. म्हणजे इट मे बी रेफ्रिजरेटर और हीट पंप. Q2 अमाऊंट सिंक कडून घेतोय आपण. W दिलं तर Q1 तिकडे जाते. तर W कॅनॉट बी 0. काहीतरी अमाऊंट ऑफ एक्सटर्नल वर्क असलंच पाहिजे. ओके. इट इज कॉल्ड ॲज व्हॉट हिअर W. It is called as here. It is called as here second Clausius statement. You will do again 2 minutes. I will give. You understood Clausius? एक्सटर्नल वर्क दिलं तरच ते शक्य आहे. म्हणून तर कॉम्प्रेसर लागतो. म्हणून तर त्याला इलेक्ट्रिकल एनर्जी लागते. चॅट बॉक्स मध्ये मेन्शन करा अंडरस्टूड आणि मग ते लिहा Clausius statement. अंडरस्टँड आपल्याला करायचं आहे. आपल्याला इथं फक्त आता मग करायची नाही कुठली गोष्ट. आता बीएमई मध्ये आपण थोडी मग केली तर चालते, पण आता इथं वे आउट टू वी शुड नॉट मग एनिथिंग. द अंडरस्टँडच केलं पाहिजे. येस अंडरस्टँड. गुड. अंडरस्टूड. ओके. दिस इज राईट डाउन द स्टेटमेंट and then I will understood. Good. Done, sir. Good, Abhishek. Your writing speed is good. Other please don't. If I will get one or two more reply, then we'll proceed. Be good done. Okay. Write down diagram. ही डायग्राम काढायची आपल्याला प्रॅक्टिस असू द्या. W cannot be equal to 0. Over. Okay. Now, very important article that we are going to see. That is called as equivalence of second law of thermodynamics. Equivalence of second law of thermodynamics. What is this? Now we have seen that. What we have seen that here two statements of second law of thermodynamics, that is Kelvin, Planck, and Clausius, are different. Different type. One is used for engine performance. One is used for refrigerator and heat pump. Both are statements are different. But when these are used in combined device, common device properly, then these statements shows a strong relation to each other. तर ते दोन्ही स्टेटमेंट एकमेकाबद्दल एवढे अफिनिटी दाखवतात, स्ट्रॉंग रिलेशन दाखवतात, त्यालाच रिलेशन टू इच अदर, अँड दॅट द स्ट्रॉंग रिलेशन दाखवणार एका कॉम्बिनेशन मध्ये, इट इज कॉल्ड एज इक्विव्हॅलन्स ऑफ सेकंड लॉ ऑफ थर्मोडायनामिक्स. Everybody getting? काय इक्विव्हॅलन्स ऑफ सेकंड लॉ ऑफ थर्मोडायनामिक्स? So both statements are different, okay, but when they have used in common device, then they will show a strong relationship with each other, affinity towards each other, and it is called as what? Equivalence of second law of thermodynamics. हे कसं प्रूव्ह करायचं? तर ओके, कन्सिडर ए फिगर. ह्याच्यामध्ये काय केलंय आपण? पहिल्या ह्याच्यामध्ये काय केलंय आपण? सोर्स टेम्परेचर T1, from that Q1 amount of heat is taken by heat engine and it is developing W amount of work. म्हणजे काय होतं, आणि इथं आपण काय म्हणले, Q2 is equal to 0. म्हणजे इथं रिजेक्टेड अमाऊंट ऑफ हीट काय झाली? 0. म्हणजे इथं काय झालं? केल्विन प्लॅंक स्टेटमेंट इथं आहे का? खरं झालं का? नाही. केल्विन प्लॅंक स्टेटमेंट मध्ये काय म्हणते की देअर शुड बी Q2 शुड नॉट बी 0. म्हणजे केल्विन प्लॅंक स्टेटमेंट इज व्हायलेटिंग. तर काय झालं? केल्विन प्लॅंक स्टेटमेंट इथं ओबे करत नाही. व्हायलेटिंग म्हणजे काय होतं? व्हायलेटिंग मीन्स नॉट ओबेइंग. लक्षात ठेवा, व्हायलेटिंग मीन्स मी व्हॉट? नॉट ओबेइंग. आता काय केलं इथं? केल्विन प्लॅंक स्टेटमेंट आपलं इथं खरं होत नाही किंवा व्हायलेट करतंय, रूल फॉलो करत नाही. ओके, पण दुसऱ्या डायग्राम मध्ये आपण काय दाखवले? एक हीट पंप आहे, रेफ्रिजरेटर आहे, हा W अमाऊंट ऑफ वर्क घेतोय आणि काय करतोय? Q2 अमाऊंट ऑफ हीट लो टेम्परेचर सिंक कडून T1 सोर्सला Q1 पाठवतोय. म्हणजे इथं काय होतंय? इथं आपण काय म्हणलंय की बाबा क्लॉसियस स्टेटमेंट इज ट्रू, आणि क्लॉसियस स्टेटमेंट इज ट्रू. काय म्हणते? कन्सिडरिंग फिगर in which Kelvin Planck statement is violating, not obeying, but Clausius statement is true. Okay. आता आपण काय केलं? एक कॉमन डिव्हाइस वापरला. काय केला? कॉमन डिव्हाइस वापरला. तर सोर्स एक टेम्परेचर T1 आणि ते सिंक घेतलं. तर ह्याच्यामध्ये हा कॉमन डिव्हाइस काय करतोय? तर जेवढी अमाऊंट ऑफ हीट Q1 सोर्स कडून घेतलेली आहे, Q1 इज इक्वल टू W आहे, त्यामुळे W अमाऊंट ऑफ वर काय केलं? रेफ्रिजरेटरला दिलं, आणि तो रेफ्रिजरेटर काय करतोय की इंजिन कडून जेवढी सोर्स कडून घेतोय हीट, तेवढी W अमाऊंट ऑफ हीट रेफ्रिजरेटर और हीट पंपला दिलेली आहे, आणि तो रेफ्रिजरेटर काय करतोय? ही Q2 अमाऊंट ऑफ हीट सप्लाय करतोय आणि ही सोर्सला तो Q1 म्हणून सप्लाय करतो. म्हणजे जर रेफ्रिजरेटर काय करते, विदाउट टेकिंग, बाहेरून कुठून घेते वर्क नाही, कॉमन डिव्हाइस मध्ये काय करते, आतल्या आतच घेते. म्हणजे हीट इंजिन आतलं आहे आणि रेफ्रिजरेटर पण आतल्या आतच आहे. तर आतल्या आतच जेवढी हीट अमाऊंट ऑफ Q1 अमाऊंट ऑफ W ते घेते आणि काय करते, लो टेम्परेचर बॉडी कडून हाय टेम्परेचरला हीट काय करते, सप्लाय करते. म्हणजे याचं ब्लॉक डायग्राम काय सांगते आपल्याला हळू, तर इथं कंबाईंड डिव्हाइस आहे, दोघींचा मिळून कंबाईंड डिव्हाइस. काय म्हणतोय, कंबाईंड डिव्हाइस मध्ये काय झालं की Q2 अमाऊंट ऑफ हीट सिंक करून घेतोय, कसलंही वर्क बाहेरून घेत नाही, आतल्या आतच घेते, बाहेरून घेत एक्सटर्नल वर्क घेत नाही. आणि इट इज सप्लाइंग Q1 प्लस Q2 इज इक्वल टू Q2, म्हणजे Q1 प्लस Q2 अमाऊंट ऑफ हीट इज सप्लाइंग टू द सोर्स. ओके, म्हणजे काय झालं, इथं कुठलं स्टेटमेंट आता व्हायलेट करतंय, म्हणजे इथं आपण म्हणतोय विदाउट एक्सटर्नल वर्क शिवाय लो टेम्परेचर कडून हाय टेम्परेचर कडे हीट जात नाही. तर इथं कुठलं विच स्टेटमेंट इज व्हायलेटिंग नाऊ, somebody can tell. स्टेटमेंट व्हायलेट व्हायला इथं, which statement is violating, please tell.
Clausius statement is
Clausius
violating.
statement is violating. का कंबाईंड डिव्हाइस मध्ये काय, विदाउट एक्सटर्नल वर्क हीट इज ट्रान्सफरिंग फ्रॉम लो टेम्परेचर बॉडी टू हाय टेम्परेचर बॉडी. Means what? Here, if Kelvin Planck statement is violated, then in combined device, Clausius statement is also violated. का, तर ते दोघांमध्ये काय एकमेकांचे काय रिलेशन आहे, स्ट्रॉंगली रिलेशन आहे. म्हणून जरी क्लॉसियस स्टेटमेंट हे पहिल्यांदा इनिशियली काय होतं, खरं होतं, ट्रू होतं, पण कॉमन डिव्हाइस मध्ये केल्विन प्लॅंक स्टेटमेंट व्हायलेट झाल्यामुळं क्लॉसियस स्टेटमेंट पण काय झालं, व्हायलेट झालं. आणि ह्यालाच म्हणायचं दोघांचं काय आहे, म्हणजे एकच व्हायलेट झालं, दुसऱ्याला पण काय वाटतं, व्हायलेट आपण पण व्हावं, म्हणून ते कॉमन डिव्हाइस मध्ये क्लॉसियस पण काय झाला, व्हायलेट झाला क्लॉज. आणि ह्यालाच काय म्हणायचं, that statement is called as, this is called as here equivalence of second law of thermodynamics. Heat engine is receiving heat Q1 from a source at temperature T1 and is completely convert this heat into work. This is a violation of Kelvin, sorry, Clausius statement. At the same time, in figure 1, हे पहिलं आहे फिगर 1, रेफ्रिजरेटर इज नाही, मगाच्या फिगरचं एक्सप्लेनेशन आहे, केल्विन प्लॅंक तिथं व्हायलेट झाला. At the same time, magaच्या figure मध्ये refrigerator is pumping the heat from low temperature to sink to high temperature source, which W amount of work and म्हणजे Clausius statement is true. आता figure 2 मध्ये काय, in combined device which makes the transfer of heat from low temperature sink to high temperature source without consumption of any external work, this violate now Clausius statement of second law of thermodynamics. Thus, if Kelvin Planck statement is violated, then Clausius statement also get violated and vice versa. म्हणजे दुसरं जरी आपण घेतलं असतं काय, क्लॉसियस स्टेटमेंट व्हायलेट केलं असतं, केल्विन प्लॅंक ट्रू केलं असतं, तर कॉमन डिव्हाइस मध्ये केल्विन प्लॅंक व्हायलेट झालं असतं. म्हणजे दस इफ केल्विन प्लॅंक स्टेटमेंट इज व्हायलेटेड, then Clausius statement also get violated and vice versa. That is Kelvin Planck and Clausius statement of second law of thermodynamics are equivalent to each other. आणि यालाच काय म्हणजे इक्विव्हॅलन्स ऑफ सेकंड लॉ ऑफ थर्मोडायनामिक्स. म्हणजे एक मित्राला समजा एका पार्टीला, एका मित्राला, दोन मित्र आहेत चांगले घनिष्ठ मित्र आहेत, एका मित्राला जर बोलवलं, एखाद्या थर्ड तिसऱ्या पर्सनना, एका मित्राला बोलवलं आणि दुसऱ्या मित्राला जर बोलवलं नाही, तर जर दोन मित्र घनिष्ठ असतील तर दुसरा बोलवलेला मित्र जाईल का, खरे मित्र असतील तर, खोटे असतील तर म्हणतील नाही त्याला बोलवलं बरं झालं, खरे मित्र असतील तर काय म्हणतील, जरी मला बोलवले पण माझ्या मित्राला बोलवलं नाही म्हणून मी पण जाणार नाही. तसं ते काय आहे, दोघांमधील काय आहे, एक स्ट्रॉंग रिलेशन आहे. म्हणून त्याला जर एक जरी स्टेटमेंट व्हायलेट झालं तर दुसरंही स्टेटमेंट कॉमन डिव्हाइस मध्ये काय होतं, व्हायलेशन दाखवतं. त्यालाच काय म्हणायचं, इक्विव्हॅलन्स ऑफ सेकंड लॉ ऑफ थर्मोडायनामिक्स. मी आय एम गोइंग टू सप्लाय नोट्स, बट आय वांट नाउ चार्ट. दिस इज व्हेरी इम्पॉर्टंट आर्टिकल, इक्विव्हॅलन्स ऑफ सेकंड लॉ ऑफ थर्मोडायनामिक्स. अंडरस्टूड? प्लीज मेन्शन in chat box. Rahul Salgare, good. First time you are telling yes. I think Sandeep Thaure, good. Yes. Now new students are joining, telling yes. Yes sir. Asmila Sarvade, very good. Arjun Ingle, Prerna Wankade, yes sir. So everybody got equivalence of second law of thermodynamics. Okay. So Deep Dumar. So I will send notes afterwards when chapter will get over. At that time, I will supply these notes to you, or if possible, today only I will supply, send, upload. Okay. Now, second law of thermodynamics. Now we'll go to the PPT. Now, I think Clausus Statements. Now, there are screen is of screen is visible. Is screen visible? Yes, sir. Okay. Okay. So, perpetual motion machine PMMK2 or SK, it is called as PMM2, PMMK2 or PMM2. Perpetual motion machine of the second kind. तर काय आहे perpetual motion machine? तर ideal machine. तर this machine is what? Without violating the first law, a machine can imagined which would continuously absorb heat from a single body, single thermodynamic, and would convert this heat in completely into work. म्हणजे perpetual motion म्हणजे it is one kind of ideal system, ideal machine. Okay, and this machine what will be there here, it is converting म्हणजे ideal आहे, काही शक्य नाही. The efficiency of such machine will be 100%. This machine is called as perpetual motion machine of second kind. म्हणजे काय, सोर्स कडून हीट घेतली Q1 अमाऊंट आणि W अमाऊंट ऑफ हीट विल बी सप्लायड. तर ह्याला काय म्हणायचं, परपेच्युअल मोशन मशीन ऑफ सेकंड काइंड. Q आउट 0 आहे आणि W नॉट इज इक्वल टू Q1, म्हणजे शक्य आहे का एवढं? ओके, ह्या मशीनला काय म्हणायचं, जे आयडियल मशीन आहे, जे शक्य नाही, ड्रीम मशीन आहे, स्वप्नातली मशीन म्हणलं चालतंय. Q इज इक्वल टू W आणि Q आउट काय आहे तुमचा 0 आहे. आणि हे थर्मल रिझर्वायर एकाशीच इंटरॅक्ट करते, सोर्सशी फक्त हीट इंजिन इंटरॅक्ट करते. हीट इंजिन दोन्हीशी इंटरॅक्ट करणं गरजेचं आहे, सिंक पण पाहिजे, त्यासाठी Q2 शुड नॉट बी 0. ओके, पण असं जर असेल तर अशी आयडियल मशीन असेल, दॅट इज कॉल्ड ॲज परपेच्युअल मोशन मशीन ऑफ सेकंड काइंड. सोर्स T1 आहे एवढं घेते आणि ह्याला म्हणायचं परपेच्युअल मोशन मशीन ऑफ सेकंड काइंड. किंवा अनादर थिंग, अनादर मशीन इज व्हॉट, अनादर इज परपेच्युअल मोशन मशीन म्हणजे काय, विदाउट टेकिंग, म्हणजे जे व्हायलेट होतं लॉ. इथं रेफ्रिजरेटर आणि RE दाखवलं आपलं. और हीट पंप. मग अशी जे व्हायलेशन ऑफ क्लॉसिस स्टेटमेंट झालतंय, म्हणजे Q2 अमाऊंट ऑफ हियर, Q2 अमाऊंट ऑफ हीट फ्रॉम सिंक कडून घेतोय, टेम्परेचर T2 आहे, and supplying in the form of what, Q1 amount to source. This without work. तर एखादी मशीन काय करत असेल, लो टेम्परेचर बॉडी कडून हाय टेम्परेचर बॉडी कडे जर हीट सप्लाय करत असेल, तर दॅट इज कॉल्ड एज ऑल्सो परपेच्युअल मोशन मशीन ऑफ सेकंड काइंड. इट इज ऑल्सो कॉल्ड व्हॉट, परपेच्युअल मोशन मशीन ऑफ सेकंड काइंड. एवढं अंडरस्टँड परपेच्युअल मोशन मशीन. मग कोण सांगते फर्स्ट PMM1 काय असतं, PMMK2 और PMM सेकंड काइंड, परपेच्युअल मोशन ऑफ सेकंड काइंड. काय म्हणणार, PMM1 काय असेल, हे दोन झाले. PMM म्हणजे काय, पर आयडियल मशीन्स झाल्या, जेणेकरून विदाउट वर्क ट्रान्सफर ऑफ हीट फ्रॉम लो टेम्परेचर बॉडी टू हाय टेम्परेचर बॉडी. आणि दुसरी गोष्ट म्हणजे काय, ऑल हीट इंजिन इज जनरेटिंग ऑल अमाऊंट ऑफ हीट इनटू इक्विव्हॅलंट वर, क्यू आउट 0 आणि इथे डब्ल्यू नेट इज इक्वल टू क्यू इन. हे झालं तुमचं PMM2. तर PMM1 काय आहे कोण सांगेल? PMM1 काय असणार आहे? हीट इंजिन विदाउट टेकिंग एनी इनपुट. हीट इंजिन काय हीट फक्त काय करते, विदाउट टेकिंग एनी इनपुट डेव्हलपिंग वर्क. काय घेत नाही वर्क, फ्युएल काय नाही ते डेव्हलप करते. विदाउट पेट्रोल गाडी चालणे, विदाउट डिझेल गाडी चालणे, विदाउट एनी फ्युएल गाडी चालणे, तर त्याला काय म्हणायचं, PMM1. विदाउट टेकिंग एनी काइंड ऑफ हीट इनपुट डेव्हलपिंग W अमाऊंट ऑफ वर्क, ज्याला म्हणायचं PMM1. Understand PMM1 and PMM2. Enter reversal process. Okay. Understand? Please reply in chat box. Understood. So PMM1, PMM2. Okay. So shall I stop today with this? But I want that everybody should revise these things because today we have taken a lot of articles. PMM1, PMM2, equivalence of second law of thermodynamics, second law of thermodynamics, limitations of first law of thermodynamics, then devices, what is meant by heat engine, what is meant by refrigerator, what is meant by heat pump, then how to calculate efficiency of heat engine, how to calculate efficiency of heat engine, how to calculate COP of refrigerator, how to calculate COP of heat pump, what is relationship between COP of refrigerator and COP of heat pump. All these things understood today's thing, please mention. Sir, please send PPT in WhatsApp group. Okay. Rahul Salgare, good. Share notes, sir. Okay, very, very good. Now mention your attendance in shall I take attendance? So roll number 1, you attendance.
Yes, sir.
Roll number 1 present. Okay, absent number 1 I am writing. Roll number 2.
Present, sir.
3.
Present, sir.
4.
Yes, sir.
5.
Yes, sir.
6.
Present, sir.
7. 7.
Yes,
Absent. 7
yes,
present.
sir.
Okay, 8. 8. 9. 10. 11.
Present, sir.
12. 12 present. 13.
Present, sir.
14. 14 absent. 15. 15. 15. 16. 17. 18. 19.
Present, sir.
20. 21. 22. 23.
Yes, sir.
23 present. 24,
Present, sir.
5, 26,
Present, sir.
27,
Present, sir.
28,
Yes, sir.
29,
Yes, sir.
30,
Yes, sir.
31,
Present, sir.
32,
Present, sir.
33, 33 absent, 34,
Yes, sir.
35,
Present, sir.
36,
Yes, sir.
37, 38,
Present, sir.
39,
Present, sir.
39,
Present, sir.
40, 41,
Yes, sir.
42,
Yes, sir.
43, 44,
Present, sir.
45, 46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49, 49, 50, 51, 52, 53, 54,
Yes, sir.
55, 56, 57, 58,
Yes, sir.
59,
Yes, sir.
59, 60, 61, 63, 64, 65, 66, 67, 68, 69,
Present, sir.
70, 71, 72,
Present, sir.
73,
Present, sir.
74, 75,
Yes, sir.
76, 77,
Yes, sir.
78, 78 present, 79,
Yes, sir.
80,
Yes, sir.
81, 81, 82, 83, 84,
Yes, sir.
over 85, over na? Over 4.
Yes, sir. Yes, sir.
Okay. You can quit the class, no problem. Tomorrow I will share the notes.
Hello, sir. 63 is present.
63, okay, I have considered 63 is present.